Okay, I want to just think about this problem. I know they give you graph, and sometimes the graphs can be very hard to understand. But over here it says, you're given something about this prior helicopter problem we have. I got something about the height. I got the velocity function. I'll write that down for you. And the velocity function, again, this is vertical velocity, is 300 minus 9t squared. All right, it certainly it's time dependent. It really is time dependent. What I want to do is I want to talk about, going up or down. And to do that, I want to find out when the velocity is actually zero. So that means 300 equals 9t squared. Let me just simplify a little bit. T squared is 300 over 9. I'm going to divide top and bottom by 3. You get 100 over 3 equals t squared, where t would equal plus or minus the square root of 10. I'm sorry, not the square root of 10, square root of 100, which is 10. Sorry about that. Over the root of 3. Now, I want to point out, I'm going to look at time. I'm not going to say time it can't be negative, but I'm going to say I'm going to stick above. And I want to talk about velocity. And where does it stop? At 10 over root 3. All right? And I want to take a test point. I'm kind of done looking at this. And the test point I'd like to choose is like 1. Plug it in. What do you get? It's positive velocity. Now, someone says, what does that mean? It's definitely going up. And then, of course, at the time where it's 10 over root 3, it's starting to change its velocity. And what happens with its velocity? It actually becomes negative. So what's a good number after 10 over root 3? I don't know, pick 10, plug it in, you definitely get a negative number. All right, get something like this over here. So I'm going to say at t equals 0, the height of it is 0. It's just lifting off the ground at 0. It's going up, and it's going up. That's what it's doing. And when it hits the time 10 over root 3 minutes, it stops, and then it starts to come back down again. All right. So what I'm going to do is I keep reading it, and I'm going to look at the acceleration now. And I hope you remember the acceleration was, what was it? The acceleration, I'll write the function down. I think we just did that, right? Turned out to be minus 18t. Now, what does that say? It says the acceleration, right? And again, we're going to start time at 0 because at 0, the helicopter's on the ground, and then it's going to move up. It's going to stop and come back down again. So what do I know about the acceleration of that time interval? It's always negative. So what does that mean? It's always slowing down, right? It's always slowing down, all right? So I'm going to say, looking at it on the time interval, I consider the graph. We got that. I see the graph. And it says, the helicopter is slowing down during this time interval. The answer is yes. It's slowing down. Now, let me make sure it says over here, the graph, helicopter, they give me the interval over here. And clearly, it looks like it's slowing down just looking at the picture, too. So the answer is yes. Let's go back over here and look at the, you know what, I got a footnote over here, too. The interval of velocity is positive, is 10 root 3. I do see that written over here. We did verify that way. And minutes contained 5 minutes. Yeah, 5 minutes. Yeah, I got that right over here. T is 5 minutes. 10 over root 3. You know what I want to do? I want to check out where is it at 5 minutes. So h of 5 minutes. Let me go back over here. That's going to be 1,500 minus 3 times 125. It's certainly above the ground. I'm not worried about that. All right. So when does it hit the ground? It hits the ground. Yeah, maybe I should do that. 300t equals 3t cubed. By the way, it's on the ground at 0. I know that. That's where it's, it's moving upward. So I'm going to divide both sides by t because I know it on the ground at 0. So it'd be 300. You know what? I'll divide by, I'll divide by 3t. You get 100 equals t squared. T is going to be plus or minus 10, by the way. So 10, again, is over here. And when it's at 10, it actually, physically is on the ground again. All right. And by the way, it certainly might hit the ground at a certain speed Maybe we should talk about how it hits the ground. If this is true, by the way, what's its speed at 10? What's its speed at 10? Let's see what happens when this thing hits the ground, by the way. And it's going to be 300 minus, it's going down, and that's going to be, that's going to be a disaster. It's going to be 9 times 100. So its speed when it hits the ground, it's going to be a colossal damage. It's 300 minus 900. So it's going to be minus 600. Minus 600 what? Feet per minute. All right? To me, that sounds like a pretty fast rate of speed. Let me write this down for you. It's minus 600 feet per minute. I may be going overboard here. I want to point out minutes. Let me put this over here because most people don't talk in minutes. Let's see. Let's put it in miles per hour. So let's write this down and see how fast it hits the ground at miles per hour, by the way. So how many minutes are in an hour? There's 3,600 minutes in every hour. I'm sorry, 60 minutes. I'm thinking seconds. Sorry about that. 60 minutes in an hour. And how many feet are in a mile? 5,280 feet in every mile. So let's just talk about this thing. It does look like it's going to be some damage here. So what do you get over here? It's, let's see, minus 36 and 3 zeros there over 5,280. And that, again, minutes cancel off. This is going to be miles per hour. And I'm looking at this and just getting a rough ballpark of it. I'm going to say, you got minus 36,000. And then I'm going to say the 5,000, roughly 5,000, let's say, or roughly 6,000, let's say. It really doesn't much matter at this point. We're just talking through it. And what's that going to go in there? And I'm going to say, maybe I misspoke by saying colossal, but it's going to hit with a big thud. There's no doubt about it. He's going to damage the helicopter. I don't think so. But it's like you're driving a car in a parking lot and you bump someone. There's some damage going to happen. All right. So, but I don't think that's the question they asked for. So the question they asked for was, we circled a yes. But let's go back over this. And it says, as the acceleration of the helicopter is negative, the velocity of the helicopter must be decreasing because the velocity is positive. We did mention that to you. And the helicopter is slowing down. So yes should be circled. Thank you.